Today's lesson, frame of reference. Our objectives. Why is a frame of reference needed to measure speed? What is the most common frame of reference when measuring speed? And how are vectors used to measure the resultant speed of two moving objects? So we begin with a simple question. How fast is this car traveling? It doesn't look that fast, but sometimes physics can appear deceptively simple. Now we could agree it's traveling about 25 miles per hour, just cruising down the road. But from this perspective, it looks like it's only moving about 3 miles per hour. So to describe how fast it's going, you'll need a frame of reference, a stationary object or set of objects, which can be used for measuring speed. For example, a set of trees could be our frame of reference. The distance between the first and last tree is 30 meters. A meter is about 3 feet long, so that's about 90 feet. Understanding that speed is equal to distance divided by time, we'd say it traveled 30 meters in 4 seconds. This means the car is moving 7.5 meters per second compared to the surface of the Earth. But the Earth is not the only frame of reference. Are we sure these trees aren't moving? Look closely. Well, the trees are part of the Earth, and it's rotating on its axis at about 1,000 miles per hour. That gives us day and night. Also, the Earth's traveling in an orbit around the Sun at over 66,000 miles per hour. So someone watching a car on Earth from the Moon could say it's moving at about 1,000 miles per hour. And someone watching a car on Earth orbit around the Sun could say it's moving at over 66,000 miles per hour. But here on Earth, we would say the car is traveling at 7.5 meters per second compared to the surface of the Earth. And since we're all here together, we don't always have to repeat from the Earth's frame of reference when measuring speed. Our next question is, how fast are these characters moving? Walter is stationary, at rest, at 0 meters per second, because he's retired and waiting to meet some old friends at the food court. But how can we measure the speed of the other two characters? The escalator is 12 meters in length, and it takes Beatrice 6 seconds to go 6 meters up the escalator, since she started halfway up. She's moving 1 meter per second. Leon goes up the entire 12 meters in 6 seconds. He's going 2 meters per second. To understand how Leon is moving at 2 meters per second, we can use vectors, measurements which include both the magnitude, how much, and the direction. Leon's speed is shown using arrows like this. He walks 1 meter per second up, and the escalator moves him 1 meter per second up. Adding these together, we find his resultant speed is 2 meters per second up. So our speeds are 0 meters per second, 2 meters per second, and 1 meter per second. But all of these speeds are based upon the Earth as a frame of reference. So now we could ask, how fast is Leon moving as measured by Beatrice's frame of reference? With Leon moving 2 meters per second up and Beatrice moving 1 meter per second up, he's moving 1 meter per second up from her frame of reference. Calculating things this way, using vectors, only works if we establish some rules, and they are: objects moving in a positive direction will always have a positive velocity. These include objects going north, east, up, or right. The opposite is also true. Objects moving in a negative direction will always have a negative velocity. These include objects going south, west, down, or left.